Okay, so we're on page 122, number 7. Or sorry, 123. 122, it's bottom 122. There we go. Page 122, number 7. You're looking at compute the cost of filling a hole 5.5 meters long, 5.5 meters wide, and 5.5 meters deep. The cost to fill is 4.75 per cubic meter. Round the answer to the nearest dollar. Okay, that was just the previous one. That sets it up. The paving contractor, a paving contractor, in determining the cost of a job, finds the number of square feet area to be paved. The shaded area that surrounds the building, as shown in the figure, is paved. All dimensions are in feet, 87 cents per square foot. Okay. So we have the building in the middle. We're going to pave around it. The building is 82.75 in both directions. Then we're going to pave 155.25 in both directions out here. To find the area, what I would do is I'd just find the area of the two squares. So the big square is 155.25 squared. Oops, something wrong there. See, 24,102.5625. Then the little area is 82.75 squared. So I'm just going to hit subtract 82.75 squared. You get a difference of 17,255. So that is square feet, that is the area. But now then it says 87 cents per square foot. So times 0.87. 15,011. Okay, something just entered in the calculator wrong. Any other questions you want me to go over?
Yeah, number 9.
Number 9, the two parcels?
Yeah.
Okay, so for number 9, we got the two parcels. This is 120, 120. Applies the total area. Find the length C. Okay. First thing I'm going to do is I'm going to find the area of this parcel here, the 120 by 120. It's 120 squared, which will be 14,400 square feet. Good, feet or meters? Square meters. And I'm going to subtract that from the 22,500. Which leaves me with 8,100 square meters. So this area has to be 8,100 square meters. So yeah, you got to square root that. That'll give you 90 feet. So that is 90 by 90 meters. You got it. So that means this whole thing has to be 120 plus 90, or 210. Any other questions?
Yeah, number 3.
Number 3?
They wanted us on B and C, or B and D. They wanted us to find the area. Or determine the length.
Length of the sides, yep. So just want you to square root it.
If two of them fingers were squared, were they?
In the answer?
Yeah, in B and D, the length given was already squared.
Yeah.
So how come we wouldn't use that to answer?
Okay. For like D, we got 0.88, so this is number 3. Yeah, 0.88 meters squared. So that's an area. When you square root that, remember we talked about when you multiply or divide, you also combine the names. In the square root and squared, we work with the labels as well. That's why if we had 2 meters and we squared that, If that was a 2 meter by 2 meter, you'd end up with 4 meters squared. When you square root it, the square root of meters squared is going to be just meters. So then you just got to do the square root of 0.88, which is going to be ugly. 0.938 meters.
I was able to figure it out. I just couldn't understand why.
Okay. Yep. Yeah, because the powers and the roots are just like multiplication and division, where you also have to operate on the names. Any other questions? Now, kind of similar to this number 9 here, where you had to take this dimension here and move it down here, and then find this dimension and add them together. This is one of the skills that we see with incoming students that is needed some improvement over the last several years, needed some work over the last several years, and that is looking at pictures like that and finding dimensions. I think I've brought this up before, but it's worth saying again over and over again. If you have a drawing like this, and let's say you're given that this is 18 millimeters and let's go 34 millimeters here. And we'll give that 13 millimeters and this 12 millimeters. Finding missing dimensions like this one and this one are a vital skill in most technical fields right now, in most trades. The way you do it, let's say I'm looking for this piece right here. Get rid of this little blue one. We've got to look at the fact that, okay, that goes from, look at it all the way down. We know now that what we have here right now is we have 2 rectangles. We have one right here, and we have one right here. In this one, in any rectangle, you know that opposite sides are equal. So the fact that this is 18 over here tells you that this whole thing is 18 over here. Well, in this one over here, same thing. The fact that this is 13 here tells you that this is 13 here. Well, what does that tell you about this piece? Well, there you go. In geometry, we're always looking for things that add up, 2 things that add up to a third. And here, the 13 plus whatever this is has to add up to 18, which means that has to be 5. 13 plus 18 is 5. 13 plus 5 is 18. So that has to be 5. And the same going the other direction. If I want to find this piece up here, I'll draw a line across here. I know that this whole distance has to be 34 because that's the opposite side of that same rectangle there. Since this is 12, this piece has to be 22. 34 minus 12 leaves us with 22. Or 22 plus 12 gives us 34. Once we know that this is 22, then this side must also be 22. And of course, that's millimeters. That's a skill that is, like I said, absolutely vital in most trades right now. And it's one that in the last 5 years or so has seemed to really need a lot more work.
I mean, that's pretty much straightforward was. The one when they got the sign, where it ain't equal.
Yeah, where I could be kind of cruel and do stuff like this. Like that, you mean?
Yeah.
That evil little laugh. I didn't mean for that to sound quite as evil as it came out. Sorry.
It's evil. It's one that I have problems with.
Make them simpler. That's no fun. let's see. I gotta make this one come out somewhat. Okay. So let's start out by finding this dimension here. Now remember, the easiest way to find that dimension is to have a reference line somewhere and know the distance to one end and the distance to the other end, and the length of that segment is just the difference in those distances. Easiest place to put a reference line, I suppose I could put it down here, but that would be that would make it a lot of extra work. The easiest place to put a reference line is usually the opposite side of the object. If I am measuring a vertical or up and down feature like this is, I need a horizontal or side-to-side reference line. Now from that line, I'm just going to move to one end or the other. To get to this end, I'm going to have to come from this direction here because that's how it connects into my reference line. So starting at my reference line to here would be how far? 18 to here. Yeah, this is still 18. 18 plus 8 would be 26 now from the reference line. So this point right here is 26 units from that reference line. Does that make sense? Now let's get to this other side, which requires we come from this way. So from here to here is 4. This is just flat across here, so that's still 4. It's still 4 units away here. How about down to here now? Another 28, so plus 4 is 32. This is still 32. Backing off to here is going to be at 20 minus 12, right? 32 minus 12 puts us at 20. So that means this is at 20. So we have 20 and 26. What's the difference? 6. This has to be 6 units. Now to go the other way, I guess I put the reference line on either side. I'll put it over here just because I'm used to having my reference line on the left side. I'm used to working left to right. Just a preference. So we're looking for this length right here. Well, to get to this end, that's pretty simple. That's just from here to here is just 14. So this end is at the same distance. That ends at 14. Simple enough. This end, of course, we got to go all the way around. So we'll start here to here is 6. This is still at 6 because that's parallel to my reference line. When we put in these reference lines, as long as we have all, no angled lines, they're all vertical and horizontal lines, either a line is perpendicular to the reference line, so it gets further away or closer to it, or it's parallel. Parallel lines don't change the distance. Since this line is parallel, both ends are the same distance from my reference line. Make sense? So this is 6. To go out to here would be 6 plus 24, or 30. This is also 30 because it's parallel. Moving back into here would be 30 minus 4 is 26. This is parallel, so this is still at 26. This is going to be at minus 6, so it'll be 20. 26 minus 6 is 20. This is parallel, so this is still 20. So the difference between 14 and 20 is 6. That's 6 units long. It'll take a while to get used to that. Any other questions? I realize there are several of you, or a few of you still working. I'm going to have you set it aside for a minute. And we're going to take a look at our new material quick, and you can finish up the quiz then when we get a chance. What we're going to look at today is we're going to start talking about, very quickly, just a brief introduction to percents. To understand percents, you first have to understand the word percent. In fact, it's actually 2 words. Per, if you think of miles per hour or miles per gallon, it's for each or out of. and cent. If you think of cents per dollar or years per century, it would be 100. So the word percent literally means out of 100. So if I have 38%, that means 38 out of 100, or 38 out of 100, like that. And it's called a ratio, but it looks like a fraction. It behaves like a fraction. The bottom number is the base, or what it's out of. We have 38 out of those 100 pieces. Think of it just like when we talked about a fraction. The denominator, the bottom number, is the whole thing, how many pieces are in a whole object, and the top number is how many pieces we have. Same thing here. That bottom number is the whole amount. Now, in fact, it is exactly just that simple to change a percent into a fraction. 38% becomes 38 out of 100. Now, we're not going to leave it like that because both of those numbers can be divided by 2. So it'll reduce to 19/50ths. Let's try a few. How about 85%? What's that going to become as a fraction? 85 over 100. Then divided by 5 is going to be 17 over 20. How about 328%? Well, it's still 328 over 100. Percent is always out of 100. But there's a couple of things we can do now to reduce this. First, it's an improper fraction. We can make it a mixed number. Perfect. 100 goes into 328 3 times with 28 left over. Now we can still reduce the fraction by 2 or 4 to get 7/25. All done? Got to put the 3 on the beginning. Very good. How about this one? 18 1/3%. Well, still 18 1/3 out of 100. Percent is always out of 100. But we don't like having fractions within our fractions. So what are we going to do to get rid of that fraction? Yeah, but that's going to be rounded off somewhere. There's a cleaner way to get rid of it. The denominator is 3, so if we multiply by 3, we get rid of the denominator. We get rid of the fraction. So on bottom, of course, 100 times 3 is just 300. On top, of course, the 3 is the 3 over 1. 18 1/3 has to become an improper fraction. 18 times 3 is 54, plus 1 is 55/3. And now, of course, the 3's cross cancel. We get 55 over 1, or just 55. From there, what can we do? Divide by 5. Get 11/60ths. So 18 1/3% is 11 out of 60. How about this one? 12.5%. 12.5 over 100, exactly. Now, just like we don't like having fractions in our decimal, or in our fractions within our fractions, we don't like having decimals within our fractions. There's only one decimal place here, so what do we multiply by to get rid of the decimal? 10. If there were 2 decimal places, we would have multiplied by 100, and so on. So this now becomes 125 over 1,000. Both of those can be divided by 5. So 25 over 200. They can both be divided by 25. 1/8. 1/8. Here you go. So we can convert a percent into a decimal, or into a fraction. Next, we're going to convert percents into decimals. We said 38% was 38 out of 100. And when we write it like this, converting into a decimal is pretty simple. Because to change a fraction into a decimal, we just divide. When we divide by 100, all it does is move the decimal point over 2 spots. So 38% becomes 0.38. 71% as a decimal will be 0.71. 250% will be 2.5. 3.8% is going to be .038. 12.5%. Yeah, that becomes 12.5%. Still got to move the decimal point 2 spots, so 0.125. How about this one? I usually catch people on this one. 1/4%. Perfect. 0.25 would still be a percent, so you still have to divide by 100 to move it 2 spots. 0.0025. Perfect. So going from a percent to a decimal, we're dividing by 100 and moving that decimal point over 2 spots to the left. If we're going the other direction, let's say we have 0.64 and we want to change it into a percent. Well, 0.64 is out of 1. A percent is always out of 100. So basically, we're multiplying by 100, which just moves the decimal point over 2 spots to the right, 2 spots the other way. That becomes 64 out of 100, or 64%. So if I have 0.91, what's that as a percent? 91%. 2.3, 230%. 0.4, 40%. 0.067, 6 and 7 cents, or 6.7%. Either way, right? How about 5? 500%. Perfect. Remember, 1, of course, equals 100%. Changing from a fraction back into a percent can be a little tricky. So let's start with one that we all know. 3/4 is what percent? 75%. There are a few different ways we could have gone about that. One, we could have just divided 3 divided by 4 to turn it into a decimal of 0.75 and move the decimal point. But there are some that don't come out quite that easily. You end up with continuing decimals like 1/3 and 2/3 and stuff like that. Another way we could have done it, 3/4 is 3 out of 4. A percent is always out of 100. And from here, we can either look at it as equivalent fractions and say, okay, 4 has to be multiplied by 25, so 3 times 25 is 75. But that's sometimes not so easy to do. For example, if we have 5/8, what do you multiply an 8 by to make 100? Well, it's actually 12.5, but that would be tough to find. So a method we have for solving these is to cross multiply and divide. Cross multiply means you take the two numbers that are diagonal from each other, in this case the 5 and 100, and multiply them. 5 times 100 is 500. Then the third number that's on the other diagonal with the missing number, we divide by. So we divide by 8, which is 62.5. So that is 62.5%. So 2/5 is going to become what percent? We cross multiply. 2 times 100 divided by 5 is 40. So that'd be 40%. How about 3/7? If we cross multiply and divide, 3 times 100 is 300. Divided by 7 is 42.857143% approximately. Correct?
Yep, that pattern.
Yep.
That pattern is beautiful.
Yep. No idea. Yes.
For me, it's easier if I take 100 divided by 7 and multiply the 3.
Okay. And that's exactly the same process. You do 3 times 100, then divide by 7. Or what you're doing, same process, you're doing 100 divided by 7, and then dividing by 3. Or times 3, I should say. Same process, just different order. You're going around like this as well. Yep. Any other questions? Okay, out of your big book. We're looking at page 180. This will be in the unit exercises. 1 through 24, if you just want to do the odds. Those are those answers in the back. So 1 through 23, the odds basically. Converting percents to fractions to decimals and back again.